acid properties, what is the function of acid properties, and why we need acid properties in transaction. So the objective is you will learn how to deal with transactions in an online manner, or how you can deal with the banking transactions. So you will learn how to practically operate acid properties with the help of the transactions. So this will be my like you can understand the concepts of the transaction practically. In addition, what would be the outcome? You will be able to operate uh, transactions smoothly. So what is the goal of the transaction management? Before discussing about the goal of transaction management, let's discuss about like what is the uh, meaning of transaction, why we need transaction, what is the process of transaction, what are the different types of transactions that are there in dbms. So let's discuss what is basically database transaction. What is basically transaction? As the name implies, transaction means to say like we are supposed to transfer information, or I can say some kind of money from account A to B. So we are dealing with transactions here. So it symbolizes a unit of work that performed with database management system or a similar system against a database, and treated in a coherent and reliable way that is independent of other transactions. So a transaction generally represents any change in the database, and in transactions in the database environment have two main purpose, like to provide reliable units of work that allow correct recovery from failures and keep a database consistent even in the case of the system failure. In addition, when execution stops completely or partially and many operations upon a database remain uncompleted with unclear status. In addition, second step is like second purpose is to provide isolation between programs accessing a database concurrently. So if this isolation is not provided, the program's outcomes are possibly erroneous. In a database management system, a transaction is the single unit of logic or work, sometimes made up of multiple operations. Any logical calculation done in a consistent mode in the database is known as transaction. And example is the transfer from one bank account to another. So the complete transaction requires subtracting the amount to be transformed from one account and adding that same amount to the other. And a database transaction by definition must be atomic, like it must be either complete in its entirety or it has no effect whatsoever. Like it could not be the case that it is living after two steps, it is living after three steps. This could not be the case. Next is consistent, like acid. So it must conform to existing constraints in the database. Like if there are some constraints, it must follow all the constraints that are there in the database. Isolated means it is not like if one transaction is performing their operation, then it could not affect any other transaction. Durable means to say it must get written to persistent storage. Durable is that which is uh, which has reflected the output, and it is not leading to the inconsistency. So database practitioners often refer to these properties of the database transaction using the acronym ACID. So what is the purpose of the same? Like database and other data stores which treat the integrity of the data as a paramount often include the ability to handle transactions to maintain the integrity of the data. So a single transaction that is consists of one or more independent units of work, reading each and or writing information to a database or data store. So when this happens, it is often important to ensure that all such processing leaves the database or data store in a consistent state. For example, like a double entry accounting system often illustrates the concept of transaction, because I am just talking about in layman term what is basically database transaction. So in double entry accounting, every debit requires the recording of an associated credit. And if one writes a check for $100 to buy groceries, a transactional double entry account system must record the following two entries to cover the single transaction, like debit of rupees 100 to groceries expense account and credit of rupees 100 to checking account. So a transactional system would make both entries pass or both entries would fail. By treating the recording of multiple entries as an atomic transaction unit of work, the system maintains the integrity of the data that is recorded. In other words, nobody ends up with a situation in which a debit is recorded but no associated credit is recorded, or vice versa. So, what are basically transactional databases? What are basically transactional databases? A transactional database is a DBMS that provides the ACID properties for a bracketed set of database operations like begin and commit. So all the write operations within a transaction have an all or nothing effect. That is, either the transaction succeeds and all the write take effect, or otherwise the database is brought to a state that does not include any of the rights of the transaction. So the transaction also ensure that the effect of concurrent transaction satisfies certain guarantees known as isolation level. So the highest isolation level is serializability, in which the records are arranged in the serial manner, which guarantees that the effect of the concurrent transaction is equivalent to the serial, that is sequential execution. So most modern database management systems fall into the category of databases that support transactions. So NoSQL data store prioritize scalability along with supporting transactions in order to guarantee data consistency in the event of concurrent updates and accesses. So in a database system, a transaction might consist of one or more data manipulation statements and queries, each reading and writing information in the database. So user of the database system consider consistency and integrity of the data as highly important. So a simple transaction is usually issued to the database system in a language like SQL that is wrapped in the transaction using the pattern that is like having the various concepts like we are supposed to deal with beginning of the transaction, execute a set of data manipulation and queries, or if no error occur, then commit the transaction. If an error occur, then roll back the transaction. So a transaction commit operation persists all the results of the data manipulation with the scope of the transaction to the database. And a transaction rollback operation does not persist the partial results of the data manipulation within the scope of the transaction of the database. So in no case can a partial transaction be committed to the database, since that would leave the database in an inconsistent state. So internally, multi-user databases store and process transactions, often by using a transaction ID or XID. So there are multiple varying ways for transaction to be implemented other than the simple ways documented, like nested transaction, for example. These are the transactions which contain statements within them that start new transaction, that is sub transactions. Multi-level transactions are the variant for the nested transaction, where the sub transactions takes place at different levels of the layered system architecture. That is, with one operation at the database engine level, one operation at the operating system level. Another type of transaction is compensating transaction. So in SQL, basically, transactions are available in most SQL database implementations because so with varying levels of robustness. For example, like we have dealt with so many queries, if you remember, MySQL began supporting transaction from early version 3.23, but in the InnoDB storage engine was not default version, that is before version 5.5. The earlier available storage engine MyISAM does not support transaction. So a transaction is typically started using the command begin, although the SQL standard specifies start transaction. When the system processes a commit statement, then the transaction ends with the successful completion. So a rollback statement can also end the transaction, undoing any work performed since begin. So if auto commit was disabled within the start of the transaction, then auto commit will also be re-enabled with the end of the transaction. So one can set the isolation level for individual transaction operation as well as globally. Like at the highest level, read committed, the result of any operation performed after the transaction has started will remain invisible to other database users until the transaction has ended. So basically what happened at the lowest level, that is read uncommitted. which may occasionally be used to ensure high concurrency, which and such changes will be immediately visible. So there are various object databases. Relational databases are traditionally composed of tables that are having fixed size fields and codes. So object databases consist of variable size blobs, possibly serializable or incorporating a MIME type. So the fundamental similarities between relational and object databases are the start and the commit of the rollback. So after starting a transaction, the database records or the objects that are logged, either read only or read write. Read and write can then occur. So once the transaction is fully defined, changes are committed or rolled back automatically, such that at the end of the transaction there is no inconsistency. Next is distributed transaction and transactional file system. So what is basically distributed transaction? So database system implement distributed transaction as transaction accessing data over multiple nodes. Our distributed transaction enforce the ACID properties over multiple nodes and might include systems such as databases, storage managers, file systems, messaging system, and other data manager. So in a distributed transaction, there is typically an entity that is coordinating all the processes to ensure that all parts of the transaction are applied to all the relevant systems. Next is transactional file systems. So the like file system for Linux support transactions and as Microsoft Windows Vista, Microsoft NTFS file system support distributed transaction across network. So there is occurring research into more data coherent file systems like WARP transactional file system, that is WTP. So this was about the basics of transaction. Now we are supposed to deal with the transaction here. What is the goal of transaction? Like we are supposed to understand the basic properties of the transaction and we are supposed to learn the concepts like underlying transaction processes as well as the concurrent executions of the transaction. So basically what is a transaction? It is the unit of program execution that accesses and possibly modifies various data objects like tuples or relations. Next is what are the properties of transaction? The Dbms has to maintain various properties of transactions like atomicity, acid properties like A4 atomicity. Like atomicity is concerned with a transaction that is an atomic unit of processing and it either has to be performed in its entirety or not at all. Consistency, that is a successful execution of a transaction that must take a consistent database state to a new consistent database state. For example, we are supposed to deal with integrity constraints here. Next is isolation. Like a transaction must not make its modification visible to other transaction until it is committed. That is, each transaction is unaware of other transactions that are executing concurrently in the system. For example, concurrency control. Next is durability. Once a transaction has committed its changes, these changes must never get lost due to subsequent system failures or recovery methods. So what are various models that are used for representing database modifications of the transaction? Like we are supposed to deal with two operations, basically read and write operation. We are supposed to read some value in the file A. There is some X value that is assigned value of the database object A to variable X, and we are supposed to write the value of the variable X to database object A. So this is basically the example of the transaction. We are supposed to read A, in which we are supposed to deduct the amount from X, that is X minus 200. Write A. So write A here will be, if it is 1000, then it will be 800. Next, read Y. We are supposed to add 100 to the same. So it would be plus 100. So it would be plus 100. So what would be the result? What would be the initial value of Y? That would be added to 100, and in the same manner we are supposed to update the operations with the help of the write operation here. If we are reading a transaction, then we are supposed to complete it till its writing. Same, we are reading any variable B here and we are supposed to deal with all the operations till its writing so that these changes could be reflected in the database. and there is no inconsistency that would occur in between. So transaction schedule reflects chronological order of the operation. First transaction is performing some operation. After the first is completing its operation, second is begin to start its operation. Now, what is the goal of synchronization? Synchronization means to say, like allowing concurrency instead of insisting on a strict serial transaction execution. That is, process complete T1, then T2, then T3. This is what serializability is like. After the whole completion of the T1, then T2 is supposed to start the transaction, and it could increase the efficiency of the system, that is throughput of the system, and minimize the response time for each transaction. So this is how our transaction previously were closed update transaction. There are certain timestamps that are associated with the same. In the timestamp 1, transaction 1 and transaction 2 are performing. If we are supposed to read the A transaction and we are supposed to deal with the variable X, then we are supposed to add some amount to X plus 200. But whatever the operations are performed by transaction 1, it could be lost because they are not updated uh, collectively. On the other hand, second concurrently transaction start that reads a variable and y. So it has added the results to the same, but in between the same write operation occur in the A. So that is why it could not be reflected, but and in the end it is getting committed. So the update performed by T1 get lost. Possible solution is T1. So locks unlock. We are supposed if we do not want any other transactions, like if we are dealing with concurrent transactions, so let the first transaction complete its all operation, because if there is any other transaction that you are starting with that first transaction, then it might be the case that you will be losing the updations, because it is not leading you to complete the first step, first transaction, and in between the first transaction you are supposed to start the second transaction, so it will lead to the inconsistencies. So that is why we are supposed to deal with the locks here. Now locks mean to say, if I am assigning log to T1, it means after the completion of the operation of the T1, I am locking it, and then T2 will start all the operations. After T2 is performing all the operations, then I am unlocking all the transactions so that it could not be leading to the updation problems or inconsistency problems. So next is serializability. Serializability means to say we are supposed to execute the records in the serial fashion. Like Dbms must control concurrent execution of transactions to ensure read consistency, that is to avoid dirty reads. A possible concurrent schedule S is the serializable if it is equivalent to serial schedule S. That is, S has the same result database state as S. So how to ensure serializability of the concurrent transactions? So this is the operation. Just have a look at the process here. T1 and Tj both are going. So order does not matter. Ti is going, it is reading operation, but it is not writing anything. So that is why order does not matter. It is simply reading, but it is not operating any operation. Like either it is performing deduction operation, or it is performing addition operation, or any other operation. So operations are not getting performed. So that is why order does not matter. But here order matters because it is writing operation and it is reading operation. So if we are dealing with writing operation, then order definitely matters. So here order matter because we are dealing with write operation. Here order matter because we are dealing with write operation. Write is concerned with, like we are supposed to make uh, reflect the output, or we are supposed to reflect the changes. That could be possible only with the help of the write operation. So that is why if where there are the write operation, then order matter. If there are no like I can say, uh, serious operations are getting performed, then no order matter. So a schedule as is serializable, which with regard to the above conflicts, like S can be transformed into serial schedule S by the series of steps of non-conciting operations. So it could check for serializability that are based on precedence graph that describe dependencies among concurrent transactions. And if the graph has no cycle, then the transactions are serializable. If it is cycle, then what will happen? It will be aborted, or they could be rolled back. So they can be executed concurrently without acting like each other transactions result. Now, how we are supposed to characterize schedules that are based on serializability testing for conflicting serializability. So this is the algorithm that is given for the same. Just have a look at the same. Look at only read item X and write item X operation. Construct a precedence graph, that is serialization graph, like we are supposed to give the priority. Either we are supposed to perform the read operation or we are supposed to deal with the write operation. So we are supposed to assign the priority. A graph with directed edges could be there, and an edge is created from Ti to Tj. That is, Ti is deriving Tj. If one of the operation in Ti appears before a conflicting operation in Tj, then the schedule is serializable if and only if the precedent graph has no cycle. Now have a look at the same. Constructing the precedence graph for schedules A and D from two tests for conflict serializability. Precedence graph for serial schedule A. If T1 is deriving T2, then there is no cycle. Precedence graph for serial schedule B. So there is no cycle. Precedence graph for schedule C. Now it is creating cycle. So that is why it is not serializable. Next D. It is serializable, equivalent to schedule A. So concurrency control loop-based protocols. One way to ensure serializability is to require that accesses to data object must be done in a mutually exclusive manner. And it could allow transaction to access data object only if it is concurrently holding a lock on that object. And serializability can be granted using locks in the certain fashion. Tests for serializability are redundant. Now there are three types of lock: shared lock, exclusive lock, and unlock. If we are talking about shared lock, then it is the read lock. No other transaction than T can write data object X, but they can read X. X lock, that is exclusive lock. T can read or write data object X. No other transaction can read or write X. Unlock data object, we are supposed to do the unlocking. So this is the compatibility matrix, that is for the requested lock and existing lock. Shared lock and exclusive lock. S lock, okay. X lock, no. X lock, no. And X lock, no. For example, X lock A has to wait until all S lock A have been released. So using lock sync transaction, like lock requirements. So before each read X, there is either a lock X or a S lock or a unlock in between. And before each write X, there is a X lock and no unlock in between. S lock can be tightened using X lock, and after X lock or S lock, sometime an unlock must occur. But simply setting locks unlock is not sufficient. So we are supposed to replace each read by S lock, read X lock, read X and unlock X, then write X, then S lock, then write X, then unlock X. So this is concerned with two-phase locking protocol, that is a transaction T satisfies the TP-LP if and only if a transaction after the rest lock X, no locks X lock or S lock occur. That is, T obtain lock but may not release any lock, growing phase, and T may release lock but not obtain any new lock, that is shrinking phase. So these are the two strict two-phase locking protocols. All unlocks at the end of the transaction with no dirty reads are possible. That is, no other transaction can write the modified data object in case of the rollback of the T. So this was about serializability, how we are supposed to deal with serializability schedule. Now let us deal with now see, I can show you the diagram of how we are supposed to deal with transaction. Just have a look at the same. So this is the process of the transaction. If we are beginning a transaction and database is consistent before the starting of the transaction, then it could be consistent after it is completing the transaction. So that is why I always say, if it is consistent before the execution of the transaction, then it must be consistent after the execution of the transaction. So this is begin transaction, this is end transaction. If database is in the consistent state before the beginning, then it must be in the consistent state after the end of the transaction. Because it might be the case that database may be temporary in an inconsistent state during execution. And why that happens? Because we are not dealing with the operations appropriately. We are not dealing with the logs. We are not giving importance to the right operation. Because in between, when we are dealing with concurrent transaction, in between we are starting new transactions. So that is what leading us to inconsistent state. So there are various facts about database transactions. Like a transaction is a program unit whose execution may or may not change the contents of the database, and the transaction concept in Dbms is executed as a single unit. So if the database operations do not update the database but only retrieve the data, then this type of transaction is called read-only transaction. And a successful transaction can change the database from one consistent state to another. And DBMS transaction must be atomic, consistent, isolated, and durable. So if the database were in an inconsistent state before a transaction, then it would remain in an inconsistent state after the execution of the transaction. So why we need concurrency in transaction? Like database is shared resource accessed, and it is used by many users and processes concurrently. For example, like banking system, railway, air reservation system, stock market monitoring, supermarket inventory, and checkouts. So not managing concurrent access may create issues like hardware failure, system crashes, concurrent execution of the same transaction, deadlock, or slow performance. So there are various states of the transaction. Just have a look at the same, because I want to show you that in that slide, but it was not possible for me. Look at the various states and various associated transactions that are associated with the same. There are various states that are there in database management system, and what are the types of states that we are supposed to determine it. So first is active state, like our transaction begin and the system enter into the active state. So our transaction enters into the active state when the execution process begin. During this state, read or write operations can be performed. Partially committed mean to say 50% operations are performed. A transaction goes into the partially committed state after the end of the transaction. Next is committed state. All the operations have been completed successfully. When the transaction is committed to state, it has already completed its execution successfully. Moreover, all of its changes are recorded to the database permanently. That is why it will be considered as the committed state. Next is failed state, like when any of the check fails or any of the operation or any of the process or any of the step of the transaction cannot proceed further. So it will lead into the failed state. So a transaction considered failed when any of the check fail or if the transaction is aborted. Aborted means to say it is stopped while it is in the active state. Next is terminated state. State of the transaction which is terminated state when certain transactions which are leaving the system can't be restarted, or it is also called aborted state because the processes will be rolled back. So these are all the states that are associated with transaction. Now let me tell you again a new diagram. Just have a look at the same, because with the help of the diagram you will be able to know the meaning of the states. So have a look at this diagram. State transition diagram for database transaction. Initially, we are beginning the procedure, that is begin transaction, then read and write operation will be taking place, then it is active transaction, then we are supposed to deal with the end of the transaction. End of the transaction is concerned with partial committed, mean to say all the operations are performed, but still it is not like updated successfully. So in the end, when we are dealing with the committed mean to say everything is complete in terms of updation, in terms of recording, in terms of everything. So next is either the system could be in the active state or the system could start in the abort state. Mean to say it is leading to the failed state, and partially committed state could also lead to the abort state. Mean to say if more operations that are associated with that partially committed state could no longer proceed, then it will lead into the aborting state. Then it will again start the process, it will be rolled back. In abort process, the transaction will be rolled back. Next is, so it is abort is concerned with the failed transaction due to like any error, power failure or any other thing that could be there. And last is terminated. After commitment, it could be terminated. So this is the procedure of the transition diagram. So how transaction moves between these various states, like once a transaction state execution, it becomes active, it can issue read and write operation. And once the read and write operations complete, that transaction becomes partially committed. Next, some recovery protocols need to ensure that system failure will not result in an inability to record changes in the transaction permanently. So if this check is a success, then the transaction commits and enter into the committed state. And if this check is a fail, then the transaction goes to the failed state. If the transaction is aborted while it is in the active state, then it goes to the failed state. So the transaction should be rolled back to undo the effect of its write operation to the database. Next is the terminated state that refers to the transaction that is leaving the system. Now look at the example of the transaction. Just wait, I am showing it to you. This is the example like acid property. Transaction 1 begin x is equal to x plus 50, y is equal to y minus 50. And so transaction 2 begin x is equal to 1.1 into x, y is equal to 1.1 into y. So transaction 1 is transferring rupees 50 from account x to y, and transaction 2 is crediting each account with 10% interest payment. If both the transactions are submitted together, then there is no guarantee that transaction 1 will execute before transaction 2 or vice versa. So irrespective of the order, the result must be as if the transaction takes place serially, one after the other. So this is the practical example of how we are supposed to deal with the transaction management. So there are various types of transaction that are there, like non-distributed versus distributed. Next is compensating transactions, transaction timings, one line versus batch transaction. So these are based on actions like two-step restricted action model. In addition, they are based on structure as well, like flat or simple transaction that are consist of sequence of primitive operations that are executed between a begin and end operation. And nested transaction, as I have discussed earlier, it is that contain other transaction. And next is workflow. So what is basically a schedule? It is the process that is creating a single group of multiple parallel transactions and executing them one by one. So it should preserve the order in which the instructions appear in each transaction. So if two transactions are executed at the same time, then the result of one transaction may affect the output of the other. For example, let me show you the example. So if like initial product quantity is 10, transaction 1 update product quantity to 50, transaction 2 read product quantity. So if transaction 2 is executed before transaction 1, then the information will be 10. Outdated information about the product quantity will be read. So schedules are required in that manner. So if transaction 2 is executable before transaction 1, then outdated information about the product quantity will be read. Hence schedules are required. So parallel execution in a database is inevitable, but parallel execution is permitted when there is an equivalence relation that exists among the simultaneously executing transaction. So the equivalence is of three types, like result equivalence. If two schedules display the same result after execution, then it is called result equivalent schedule. They may offer the same result for some value and different result for some other set of values. For example, like one transaction update the product quantity while other updates customer details. Next is view equivalence. View equivalence occurs when the transaction in both the schedule perform a similar action. Like example, one transaction insert product details in the product table while another transaction inserts product detail in the archive table. So that transaction is same but tables are different. Next is conflict equivalence. So in this case, two transaction update view the same set of data. There is a conflict among transaction as the order of the execution will affect the output. Next is serializability. So it is the process of search for a concurrent schedule whose output is equal to the serial schedule where transactions A execute one after the other. So depending on the type of schedules, there are two types of serializability. First is concerned with conflict, second is concerned with view. So what we have learned in transaction management is that it is the logical unit of processing in Dbms, which entails one or more database access operation, and it is the transaction that is a program unit whose execution may or may not change the contents of the database, and it could not manage concurrent access because it may create issues like hardware failure and system crashes. Active, partially committed, committed, failed, and terminate are important transaction states. The full form of ACID properties in Dbms is atomicity, consistency, isolation, durability. Three Dbms transaction types are based on application areas, action, and structure. A schedule is the process that is creating the single group of multiple parallel transactions and executing them one by one. Serializability is the process of search for a concurrent schedule whose output is equal to the serial schedule where transactions are executed one after the other. So we can deal with example here like transaction to be performed to withdraw cash from ATM. So set of operations like there are various examples of the transaction operation like transaction start, insert your ATM card, select language for your transaction, then select saving account option, enter the amount you want to withdraw, enter your secret PIN, wait for some time for processing, collect your cash, and then transaction completed. So these three operations can be performed in the transaction like read, access data, or write, change data, commit data. So these are the transactions that are concerned with read, write, and commit. So basically, we are supposed to deal with three operations here: read, write, and commit. Because let's say, as I told you in earlier example, like we are supposed to deal with the transfer of from funds from account A to B. So what would be the uses of the transaction management in that case? Because DBMS is used to schedule the access of data concurrently. It means that the user can access multiple data from the database without being interfered with each other. And transactions are used to manage concurrency. It is also used to satisfy the ACID properties. It is used to solve read or write conflicts. And it is used to implement recoverability, serializability, and cascading. In addition, transaction management is also used for concurrency control protocols and locking of data. So we have already discussed, but what is the disadvantage of transaction that we have not discussed? So there are certain disadvantages that are concerned with transaction, like it may be difficult to change the information within the transaction database by end users, and we need to always roll back and start from the beginning rather than continue from the previous state. So these are the advantages that are concerned with the transaction. So just look at the summary. We have studied about transaction concepts, properties of transaction, serializability of transaction, testing of serializability, and two-phase commit protocol. So these are all the concepts that have been discussed in today's class. So this was all about my today's class. Reference link is given here. If you want to have a look at the same link or same lecture, you can refer to this link that is given for your reference. In addition, today's MCQs are given. 10 MCQs are given, and each question is having four choices, and you are supposed to take any one answer out of four choices. At the end of the class, you are supposed to submit the answers. So 10 questions are there. Just have a look at the syllabus. So this was all about my today's database class. Thank you. Have a nice day.